To live means to communicate. For a long time, 2 copper wires were sufficient. But with today's huge numbers of bits and bytes to be transferred, 2 copper wires cannot handle it anymore. An ideal solution, the fiber optic link. Handling of the hair-thin fibers requires a large amount of skill and know-how. The single fibers of up to 12 kilometers length are colored for identification. In this special cable, 10 fibers are inserted into 2 stainless steel loose tubes each, which in turn are part of a high tensile stress steel wire cable. Since this new type of cable is designed to be used in great depth, bitumen is added during the stranding of the cable to achieve optimal longitudinal impermeability. The preforming of the cable is done to achieve long-term dimensional stability. In the extrusion line, a high-quality polyethylene outer sheathing is added. Immediately before the last extrusion, the cable is pulled through hot bitumen. Rotating printing heads mark cable length and cable type on the submarine cable before it runs through the final water cooling bath. The total length of approximately 5.5 kilometers of submarine cable with an outer diameter of only 16 millimeters will fit easily on a medium-sized cable drum. Early in the morning, the rope leaves our factory. Destination is Lake Sils in the Oberengadin in the eastern part of Switzerland, where the cable is to be laid in a depth of 70 meters. The reason for this is the beginning of a new age of telecommunication for this part of Switzerland, without disturbing nature in any way at all. This type of work generated a few extraordinary requests from the local authority, as well as from our installation team. The help of the police and the fishery department is a must. The cable must be buried along the deepest waterline of the lake to prevent a possible later shifting of the cable to even deeper ground. In the shore regions, protective pipes have been installed. Now, the important navigational points are marked with buoys. The local district police assists us with their know-how and equipment for this critical task. With the help of a depth-sounding device, the deepest points are located and marked with buoys. In order to sink the cable in a straight line, in spite of the anticipated heavy crosswinds, the decision was taken to pull the submarine cable with a motorized winch. For this reason, a pulling rope was installed first. From the winch, this rope is pulled to the starting point in Maloja. At the point of the first direction change, a pulley is installed. To prevent the pulling rope from sinking, floats are prepared and positioned under the rope at 100-meter intervals. This method was developed by Brook and has proven itself many times over the years. The boat of the fishery department starts to install the pulling rope. With the increasing adverse winds, the police jet boat has to assist to maintain a straight line. The pulling rope is safely installed by nightfall. The next step is to pull the float with the cable drum to the second point of directional change. For the final part, the float is pulled by boat. In the morning, all that suggests the approaching great events are protective pipes sticking out of the water. To be able to pull the drum with the submarine cable across the lake, our carpenters had to construct a float with 4 military pontoons. With a capacity of 6,000 kilograms, by far the largest floating vehicle on Lake Sils for quite a time. The cable is then pulled through the protection tube into the cable pit and temporarily secured. The pulling rope is tied to the float and the winch takes up slack. Slowly, the floats begin to move. Divers flood the protection tubes on the shoreline and secure them at the bottom of the lake. Continuously in the correct and pre-calculated angle, the cable is lowered to the bottom of the lake. The divers continuously monitor the correct position of the cable on the bed of the lake. At the first point of direction change, the floats under the pulling rope must be brought to the other side of the installation pulley. Once the float has passed this position, the pulley can be removed. The winch operator is in constant radio contact with the crew on the float. He is controlling the speed of the float and could stop immediately in case of emergency. Under the critical view of onlookers, the float has reached the second point of direction change. The float manages the last section of the cable run with the help of a powerboat instead of the winch. At the final destination, a diver awaits the cable to be pulled into the cable pit. And to everybody's relief, the length of the cable proved to be correct. Once again, the protection tube is flooded and secured to the lake bed. Before the daily thunderstorms set in, the work is completed on schedule. A last step of the installation is to measure all the fibers to make sure nothing has changed during the installation. For this, the outer polyethylene sheathing of the cable has to be removed in order to get to the stainless steel loose tube. The outer steel wires are cut halfway and then broken off. After thorough cleaning, the hot cores of the cable are revealed and the other wires are cut. Carefully, the stainless steel loose tubes containing the fibers must be cleaned and straightened. With a special cutter, the loose tube is cut in order to free the actual fibers. In a mobile measuring laboratory, the primary coating is removed from each of the fibers. A cleaver is used to scratch and break the fiber in an exact angle of 90 degrees. With the help of the automatic fusion splicer, the two fibers are joined very accurately. With the optical time domain reflectometer, each fiber is measured at 1300 and 1500 nanometers. After completion of the installation, Lake Sils presents itself once again in its natural beauty, and only insiders will know that a thin cable of 16 millimeters diameter will connect the entire Engadine Valley with the rest of the world, safely and securely for many years to come.